So now that we've done a z-test for two proportions, we can construct confidence intervals. We use the z-test for proportions to test if two proportions are different from one another. After the z-test, we can construct confidence intervals to estimate how large that difference actually is, if it's a small one or a large one. So for this data, which I used in the last lecture, I have two sample sizes, which are both 200, and I have two proportions, 0.32 and 0.46. So construct a 95% confidence interval for the difference of these two means. Now remember that a confidence interval is just a point estimate plus or minus a margin of error. So you're going to get two values, a lower bound and an upper bound. And these are the equations for lower bound and upper bound. You can see that it includes stuff we pretty much already know, the two sample sizes and the two proportions. So I can just put that in there, and all we really need to find now is what our z is. Now I'm saying construct a 95% confidence interval, so that means your alpha level is 0.05. And split into two tails, that means you have about 2.5% in each tail. So if you have 2.5% in a tail, that means you have about 97.5% in a body, and that means your z-score is about 1.96. If you're unclear about what I just did there, you can go back to one of my previous lectures on z-scores, but this is how I get my z-score of 1.96 using this z-table that I'm showing you right now. So instead of z, I put in 1.96. And now we have everything we need to solve for the lower bound and the upper bound. So I find a lower bound of 0.045 and an upper bound of 0.235. So we are 95% confident that the mean difference between the two proportions is somewhere between 0.045 and 0.235. And that's how you construct confidence intervals for the difference of two proportions.